Okay, I know we learned this in chapter 1 as well, girls, but we are back talking about intercepts again, and we're going to look at the intercepts on a linear equation. Just as a reminder, an x-intercept is where the graph crosses the x-axis, the y-intercept is where it crosses the y-axis, and it's important to note that the x-intercept is when the y value is equal to 0. It's also known as the root of the function, or the 0. And the y-intercept is where the x value is equal to 0. A special thing to note about linear equations is that linear equations always have exactly one x-intercept, exactly one y-intercept. Except in this special case with a vertical or horizontal line that's on the x-axis or on the y-axis, you're always going to have one x-intercept, one y-intercept. So let's take a look at some examples. Let's say you're looking at this graph and you wanted to find the intercepts. The x-intercept is where it crosses the x-axis, so that's the 20. You could write it as a coordinate point, 20, 0, or you could write it in function notation, f of 20 equals 0. The y-intercept is where it crosses the y-axis. So in this case, you'll notice that this is a scale of 5s. It's going 5, 10, 15, 20. So that's how I got that this is at 30, y equals 30. As a coordinate, that's 0, 30. And in function notation, it's f of 0 equals 30. Remember, it always goes the x here, the y here. What if we were trying to find intercepts on a table? Let's take a look at this example. It says a swimming pool is being drained at a rate of 720 gallons per hour. The table below shows the function relating the volume of water in a pool and the time and hours that the pool has been draining. We want to find the intercepts of the function. So if you're looking at this table, you'll notice first that there's 2 zeros on here. Remember, when x is 0, that's the y-intercept. When y is 0, that's the x-intercept. Now to interpret those points, the y-intercept always tells you the starting value. So in this case, it's saying that the pool started with 10,080 gallons of water. The x-intercept, you can kind of think of it as where does it finish or where does it end. In this case, it's saying that it takes 14 hours for the pool to finish draining. Let's do one more example of finding intercepts from an equation. Let's say we were finding the x and y intercepts for the graph of 2x plus 4y equals 16, and then we're going to graph the function based on the intercepts. Let's do the x-intercept first. Remember, that's when y is 0. So you're going to substitute in 0 for the y value. So it should look like this. 2x plus 4 times 0 equals 16. We just talked about how anything multiplied by 0 is always equal to 0. So then you can solve this. 2x plus 0 is just 2x. And then to solve 2x equals 16, you're going to divide both sides by 2. To get the x by itself, x is equal to 8. As a coordinate, you could put that as 8, 0. The x is 8, the y is 0. Now for the y-intercept, you're going to plug in 0 for x. So it's going to look like this. 2 times 0 plus 4y equals 16. 2 times 0 makes 0. 0 plus 4y is 4y. And then to get the y by itself, you have to divide both sides by 4. So you get 1y equals 4. The y-intercept of this equation is 4, which could be written as the coordinate 0, 4, because x is 0, y is 4. Okay, so on the graph, if we're trying to graph this linear equation, 2x plus 4y equals 16, we would plot our 2 points. The x-intercept is at 8, 0. The y-intercept is at 0, 4. And then 2 points is enough to make a line. You just connect the 2 points with the best line that you can. And there you have it. That's the graph for the line 2x plus 4y equals 16. As a review, is this in standard form? Why or why not? Go ahead and write your answer down. Hopefully you said your answer was no. That was not standard form because it didn't have a greatest common factor of 2. A greatest common factor of 1. It had a greatest common factor of 2 instead, between 2, 4, and 16, A, B, and C. So in order to put that in standard form, you would have to divide out the common factor of 2. So this equation in standard form is the same as x plus 2y equals 8. So if you graphed that line, it would look the exact same as the line we just graphed. Remember, everything that this line crosses is a point on the graph. So for example, like it looks like it's crossing through 2, 3. It kind of looks like 3, 2.5, I would estimate, 4, 2. These are all just estimates, obviously. I'm not actually plugging numbers in here. But those are all points on the graph. Even the ones in between there, those are all points on the graph. Since those are all points on the graph, if you're trying to answer the part of the question where it said, tell me the domain and the range, that's going to be, the domain is, remember, all the x values. So in the past, we would just list out all the x's for every point, or all the x's that were in the table. But since this is infinite amount of x values to the left and to the right, we have to say that the domain goes from negative infinity to positive infinity. On the graph, you want to look at it from left to right. Since it's pointing to the left forever, that means that every single x value all the way to negative infinity is going to be covered. And since it's pointing to the right forever, every single x value all the way to positive infinity is going to be covered. Think of it on your number line. Negative infinity is on the left, positive infinity is on the right. This whole graph is covered from negative infinity to positive infinity with a highlight if you look at it left to right. Now, the range is the y values. That's this axis here. So we're looking at it from the bottom of the graph to the top. You'll notice that this side of the graph points down. So on the bottom of your y-axis is negative infinity, meaning that this range, it starts at negative infinity. These y values are going to eventually reach down to negative infinity. Similarly, on the other end, over here, it's pointing up. So it's eventually going to reach all the way up to positive infinity. Looking at the graph from the bottom to the top, everything is covered from negative infinity up to positive infinity. It turns out that this is actually the domain and range for every straight line that's a slanted line. Obviously, this doesn't work for horizontal and vertical, but this is always the domain and range for a linear function as long as it's not vertical or horizontal. Remember, another way to say that, negative infinity to positive infinity, that interval, is all real numbers. So if you run into that, you know it means the exact same thing. Alright, I want you to try this one now. Find the 0 for the function f of x equals 3x plus 3. Hopefully you remembered from the vocab that a 0 is the same thing as an x-intercept, which means that you should be plugging in 0 for y to find it. We know that function notation f of x is the same thing as y, so I can rewrite my equation first, y equals 3x plus 3, but then I plug in 0 for y, so it's 0 equals 3x plus 3. Now I have to solve it for x. Subtract 3 on both sides, divide both sides by 3. You should have gotten negative 1 for x. Another way to write that answer is as a coordinate point, so that would be negative 1, 0, or in function notation, f of negative 1 equals 0. Pay attention to what the directions tell you to figure out how to say your final answer and what format to put it in. Okay, last one, some extra practice. Find the x and y intercept of the line with the equation 2x plus 3y equals 6 and graph the line from the intercepts. I want you to try this one by yourself as well. Here are the answers, including the work for the x-intercept and the y-intercept. Now let me show you the graph. Here's what the graph should look like on a coordinate plane by using the two intercepts, 3, 0 and 0, 2, and then connecting them with a straight line. That wraps it up for our review of x and y intercepts and learning more about how to find them from an equation and use them to draw the graph of a straight line. I hope you learned a little bit more about x and y intercepts today. When you come back, we're going to talk more about straight lines and learn something called the slope of the line. So talk to you soon. Bye, girls.